Hello again. So let's look at a specific reaction in this case, the reaction of hydride. So this is the simplest example in our chapter looking at nucleophilic addition to polar pi bonds. So if you have a carbon double bond to an oxygen, you have a pi bond system, we can do these reactions. Carbon double bond to a nitrogen, same thing. The really common reactions in organic chemistry, things that people use a lot, are sodium borohydride, NaBH4, and lithium aluminum hydride. For our purposes, we're going to use these as H- sources. Right? H- is hydride. When I say hydride, I mean H-. Right? So this is a really good nucleophile. It's going to work in these reactions and basically take the place of the Nu in the practice ones that we've looked at. So if I start a reaction and I add some NaBH4 and some H2O, I can turn a ketone into an alcohol. Right? And what you'll actually get here is a mixture of stereoisomers. That's something that is covered in the book in a little bit more detail, but the reaction starts without any chiral center here, but we've gained a potential one. But there's no preference towards one another, so one or the other, so you do get a mixture in this case. What's the purpose of the water? Right, so remember, we need a nucleophile, H- source, and then for our mechanism to work, we also need something to do a proton transfer in the end, and that's where the water is going to come in. Right, so I can do this reaction with sodium borohydride. I can do this reaction with lithium aluminum hydride as well. Right, with lithium aluminum hydride, use a little bit of a stronger acid. H3O plus is our generic for a stronger acid there. It's going to give the same product. Right, just two different ways to do it. Lithium aluminum hydride is actually more reactive, which can be useful at times. So mechanism wise, anytime you see these two reactants, we're going to pretend it's H-. That makes things a lot easier. So I've got H- now, right? So let's pick a different color. Right, this follows the same pattern as our generic. H- attacks the carbonyl carbon of this ketone, right? So this is a polar bond, which means this carbon is more negative. The more electronegative oxygen is more negative. So minus is attracted to positive. That starts my reaction off. And I have O-, and a new hydrogen is added here. So then at that point, the water becomes useful. Proton transfer step, seen those before. Right, I've made a new alcohol, that's my mechanism. You want to do this for the lithium aluminum hydride, it's the same thing. Right, really no difference there. This is a shortcut. It doesn't actually work this way. Hydride H- doesn't actually get formed in solution. If you look at my notes, it shows a version of the actual mechanism, but this is the one we'll use going forward. This is the mechanism to know.